Hello everyone, welcome to YourPedia Education. So today we are going to discuss some important questions from electromagnetic field theory. Right, it is most important question for your BEL and BDL exam. So let's start the video. The first question is correct vector identity is. That is, which one of the following is the correct identity? See, first is divergence of a, this is the vector field. Remember, A is the vector field, V is the scalar. So this is the identity that is not correct, right? The second identity, what it says that is the divergence of a, this is a scalar quantity, A is the vector. Remember that thing here, right? If I write it, that will be A times gradient of a scalar, right? Plus, what is the next? V is the scalar quantity multiplied by the divergence of a vector. This is the correct identity, right? Because if you go here, that is A dot V, that is correct, but it is a vector. You can't add a vector quantity because you multiply a vector with a you can say this divergence will going to be a scalar quantity. If you multiply a vector with the scalar quantity, that will become vector, but this is a scalar quantity, so they can't be added. So this identity is not true. You can see here, this is divergence. Divergence cannot be calculated on a scalar quantity, it will be calculated on a vector quantity. The same thing is here. So that is the main thing. Answer is B, right? Remember this. This is the product rule, right? Okay, next question. For a vector field A, which one of the following is false? See, if I am talking about the false statement, let's do one by one. The first statement, del cross A means curl is another vector field. Obvious, that is obvious, because if you take a curl is always a vector quantity. So that is true, not false. A is a solenoidal field if del dot A equals to 0, right? It is also true that if del dot A is equals to 0, that will be a solenoidal field, right? If A is a vector quantity, then twice of del dot A is equals to 0, then it is irrotational. See, if your vector field A is irrotational, that is del square A, not del 2A, right? Del square A is equals to 0. If your vector field is irrotational, that means its curl is 0, right? If your vector field is irrotational, that means its curl is 0. If your vector field is solenoidal, then its divergence will be 0. That is the thing. Last identity will be correct. So what will be the answer? This is answer. This statement is not correct, right? Next, a vector field A and B is given to you, then we have to find the magnitude of this vector 5A, that is 5 vector A, right? 5A minus 2B will be. So remember one thing, first we have to multiply by 5 to the A, then we have to subtract 2 times B from this one. So multiply the 5, each quantity of this one, right? This is plus here. Let me check it. Yeah, it should be plus 15, no plus, yeah. It should be minus, no plus, right, correct. This is plus. So if you multiply this one with 5, this complete quantity with 5A is become how much? That is become minus 20AX plus, next is 10 times AY, next is plus 15 times AZ, correct? 5. Next is 2B, that is 6AX cap. Then it is 8 AY cap minus 2 AZ cap. When you subtract these two things, you will get this. Subtraction will be done when you are doing the vector subtraction. AX will be subtracted from AX, AY will be subtracted from AY, like that. So you will get 26, 2 and 17. So if you find the magnitude, you have to square 26, 2 and 17, that will be 969. So what will be the answer? Answer will be A. So if he asks for the magnitude and you have the quantity like this, you have to add or subtract. So do that, multiply with the scalar quantity, then addition of you can say the x component with x component, y component with y component, and z component with z component. Then if you are taking the magnitude means under root of x component square plus y component square plus z component square. That's all about this. Okay, the next, the divergence of D is see, always remember, whenever you are calculating the divergence, divergence means dot product with a vector quantity, that is always a scalar. That is always a scalar point function, right? Next, if the line integral of a vector field depends only upon the coordinates of 2 points, remember, if the line integral of a vector field depend only upon the 2 coordinates and independent of the actual path taken between them, then the vector field is said to be, see here, let us take, we have 2 points, this is A point, this is our B point, and we have a vector field, right? We have a vector field here like this. This is a vector field, A point, B point, let us take E is a vector field here. So basically, if you calculate its line integral along A to B, E dot dl. dl is the path which is shown along this path, right? This is the path from A to B. Either you go from this path, either you go from this path. If you are going from A to B, and either you go from this path or this path, any path, but the value of the line integral is only depend of these 2 positions, A and B. It is not depending on the path. Then the vector is called as conservative vector. A vector is called as conservative vector if its line integral will only depend on the initial position and the final position. It will not depend on the path in between these two things. Then that is called as conservative vector. If you make a closed path here, you go from A to B, then B to A, then this closed line integral for a conservative vector become 0. That is the main thing. So what will be the answer? That the vector is conservative in nature. Answer will be D. A theorem that relates the surface integral with volume integral, that is called as Gauss divergence theorem. Gauss divergence theorem relates your surface integral with volume integral. So answer will be B. The Poisson equation for a inhomogeneous medium. See, if your medium is inhomogeneous, then the Poisson equation is del square V minus rho V upon epsilon. This is your Poisson's equation, right? If your right hand side is 0, if your medium is charge free, for charge free medium rho V is going to be 0, so del square V is equals to 0, that is called as Laplace equation. Del square V is equals to 0 is the Laplace equation, right? Curl of a gradient may also be written as curl of a gradient. So that means curl, that means del cross del phi. Phi is a scalar quantity, so that is becomes vector quantity. And if you take curl of a divergent, curl of a gradient, that is always 0. Remember, that is written like this. So curl of a gradient is it is misprinted here. That is curl of a gradient, right? Like this. That will be the answer, right? And it is always equals to 0. Is a vector field defined each point of a scalar field? That is a gradient. Gradient of a vector is a vector which is defined on each point of a scalar field, right? It is a vector quantity, and that will represent the maximum magnitude, maximum rate of change of magnitude, right? And the direction of the gradient will show you the direction in which your maximum rate of change will occur. Two vector v1 and v2 are orthogonal. See, whenever two vectors are orthogonal, their dot product will be 0. A is equals to this, then B is equals to this. We have to find the projection of B on A. If you are finding the projection of any vector, then what you have to do, the formula for the projection is, let us take you are finding the projection of B on A. So then it A dot B divided by the magnitude of A vector, that is called projection of B over A. So B on A, right? So we have to find the dot product of A and B. So if you find the dot product, then it will be 2 into 3 6, 2 into 2 minus 4 minus 1, that will be 1, and the magnitude of A is 4, 4 plus 9, 9, 3, that is 1 by 3. So it is going to be 1 by 3. That's the answer is A. So basically in this type of exams, the calculation are not too difficult. They are the easy calculation. If you know the formula, you can do that. So sometime he may ask about this projection. If you are calculating the projection means what? If I am talking about, let us take this is A vector, this is B vector. If you project this vector B on A vector, right, that is the projection of B. Projection of B vector over A. This is A vector, this is B vector. That is the projection of B on A. For the vector field A and B is, okay, he is asking for this quantity, that is divergence of vector A, that is cross here, A cross B is. So first we have to find the A cross B. So A cross B is how much? This one. This is the matrix form. You can find it AX, then it is multiplied here, it is multiplied here, then AY minus AY, then it is multiplied here, it is multiplied here, right? And the AZ, when you take AZ, that will become 0. So what you are seeing, YZ, XZ. If you take the divergence of the curl, right, the divergence of it, not the curl, the cross product of two vectors, so it is become the, take the derivative with respect to X, take the derivative with respect to Y, both are going to be 0 because there is a no X term, there is a no Y term in the second term. Next question. Which of the following is related with Stokes theorem? See, basically if I am talking about the Stokes theorem relates the surface integral with line integral. So Stokes theorem says the closed line integral of a vector field F is equals to the surface, this is the open surface integral of the curl of that vector field S. So that is relate the surface integral with line integral with surface integral. The answer will be C. The Laplacian of a scalar field. See, remember one thing, Laplacian operator is divergence of a gradient, right? Divergence of a gradient, sometime we will write it del square V. So that is divergence of a gradient. So what will be the answer? Answer will be the D, divergence of a gradient. Solution of Laplace equation which are continued through the second derivative is called as, see, whenever we are going for the solution of the Laplacian equation, that are the harmonic functions, remember that thing, right? The next thing is you are calculating this one, this is the where P is the vector field, this is represent closed surface, open surface integral, that will relate this open surface integral of del cross P with the closed line integral. So answer will be the closed, that is the Stokes theorem, you can say like this. The divergence of a vector field that is given to you, the divergence of this vector field. So if you are calculating the divergence, you have to take the derivative of first x component with respect to x, that is going to be 1, plus you have to take the derivative of this second component with respect to y, that is also going to be 1, and you have to take the third derivative of the third z component with respect to z, that is also going to be 1. So answer will be 3, answer will be D if you are taking the divergence. Gauss law relate the electric field intensity with the volume charge density rho v as, what is the relation between these two? See, if you remember the Gauss law, the point form of the Gauss law is del dot D is equals to what? Rho v. If you have D, the electric flux density is related to by the electric field intensity epsilon E is equals to rho v. So if your medium is homogeneous medium, epsilon will come out. So del dot E is going to be rho v upon epsilon. That is the relation. The relation will be del dot E D is equals to rho v upon epsilon naught. If your charge free medium, right, like this. So that will be the D answer. You can check it here. Okay, one more thing. If I'm talking about the del cross H, so basically del cross H is what? J. J is the conduction current density. I am not considering this term right now, but it is also the this is called displacement current density. When we discuss about this, we discuss about in detail. So basically, this is the current density. Current density unit is ampere per meter square. Sorry, ampere per meter square. So what will be the answer? Answer will be C. So current density unit, because it is equivalent to what? Current density, and current density is the unit of the current density is ampere per meter square. Electrostatic field is said to be conservative when, see, I already discussed that thing. A field is calculated conservative when its curl is equals to 0, right? Curl is equals to 0. So it's whenever its curl is equals to 0, then you can say the vector field is conservative in nature, or you can say the line integral will be 0. From the line integral, closed line integral, I already discussed that thing. Closed line integral of a vector field E dot dl is equals to 0. Then we can say by using the Stokes theorem that del cross E dot ds is equals to 0. This is only 0 when del cross E should be equals to 0. So what we are seeing from this relation, we are seeing that for a conservative vector field, electrostatic field, you can say the curl of that field should be 0, right? The electric field intensity del dot del, or if you are always finding the divergence of a curl is always 0, remember that thing, the answer will be 0. This is the equation del dot j is equals to 0 is known as the continuity equation for the charge free region. What is the exact continuity equation? If you remember, that is del dot j is equals to minus del rho v over del t. So if you have a static charge, or charge free region, then del dot rho v over dt will going to be 0, right? The line integral of a vector potential around the boundary of a source represents the following relation. Okay, line integral of a vector potential is A, right? The line integral of a vector potential A around the source, if you are taking the closed line integral, that will represent the flux, remember, magnetic flux. So it is representing both magnetic flux or magnetic flux density. An electrostatic field between two point charge are increasing when they are electrostatic force. See, if I am talking about electrostatic force, F is equals to what? Q1 Q2 upon 4 pi epsilon naught r square. So what you are seeing that if distance is increasing, force will decrease. If charge magnitude is increasing, force will increase. So more apart and dielectric constant increase if he is asking. So the distance between these two is very small, and you can say the epsilon epsilon r, if you want to increase the value of f, epsilon r should be small and r should be small. So less apart and dielectric constant of the medium then decrease, right? That will be the answer is B. So that is the relation. A charge q is enclosed by a Gaussian spherical surface of radius r. If r is double than the outward flux. See, whenever we are calculating the flux is charge enclosed divided by epsilon naught, or generally you can say the phi. This is the electric flux, right? So if we are talking about the flux is depend only on the charge enclosed. It will not depend on the thing that your surface is where your surface is enclosed, that thing, its shape and all of the thing, it will not depend on that thing. If your surface is enclosed, that either it is having radius small or higher, but it will depend only on the thing that your how much charge is it will be enclosed. So charge will remain same. If your radius is increased, charge will remain same, so flux will remain unchanged, right? That is the main thing here. Which of the following represents the Maxwell divergence equation for the static field? See, if you am talking about the static field, then the equation del dot B is always true. It is for static and dynamic for both the things. Del cross H is equals to, see, del cross H is equals to what? Del E over del T, or you can say that minus del E over del T. So this relation is for static field. If your E field is static, then the del D over del T is going to be 0 sigma, something like that, right? Which of the following statement about the electric field line associated with the electric charge? Electric field lines, see, there are two field line, one is electric field line, another one is magnetic field line. If I talk about the electric field line doesn't make a closed loop, you can say like that, and and magnetic field line always make a closed loop, right? Because in electric field you can say that positive charge and negative charge cannot be exist together, but in magnetic field we can say the north pole and south pole cannot be separated. So that's why if I'm talking about the magnetic field is always making the closed lines, and electric field never make a closed path, closed line, right? You can say like this. The answer will be electric field line form closed loop. Electric field associated with electric charge is false. Yeah, he is asking about the false, so that will be B. A continuity equation is also called as law, that the continuity equation is based on charge of conservation, right? Charge conservation. The potential V is given to you, so electric field you have to find the what is the relation? Electric field is minus gradient of V. You have to take the gradient. So what will be the gradient? You have to take the derivative with respect to x, that is going to be 4, and that the derivative remains 0. So what will be the answer? That is minus 4, and the only x component is there, then it will be Ax. So answer is D. Yeah. Application of method of image charge to the boundary value problem in electrostatics involve which of the following? See, whenever we are talking about the image charge, right? Image charge. Let us take you have a perfect conducting ground here, and you put a charge here. So what happens? This charge attract the electrons from the ground, and so there will be negative charge there on the surface. But what we can do? We can't not analyze that thing. So what we can do? There is an image charge method. It says that this is the positive charge at a distance. Let us take r distance above this ground. So we can replace that ground, and we will make a negative charge at the same distance from the ground. Let us take it, this is r from the ground, the distance will be the remain same, that is r also for the negative charge. So the effect of that surface charge density which is induced over that ground, perfect conducting ground, that will replaced by that minus q charge, and you can find the electric field and everything above that ground, because below that ground there is nothing, because electric field only exists above the there is no electric field inside the conducting ground, you can say like that. So what will be the answer? Introduce an additional distribution of charge and removal the set of conducting surface, that will be the answer. So these are the important questions, and more questions. If you join our module, we are going to launch a module for dedicated module for those students which want to prepare for the BEL exam, and they have given the GATE exam. If your GATE exam is not that much good, you can join this module. This is the important module. In this module we are going to discuss only questions, right? Hundred or thousands of questions from each subject. We are going to give you around 100 or 120 questions video like this, right? And I will continue this video on that module. If you want, you can if you want to prepare for BEL exam and your GATE exam is not that much good, that is a good opportunity for you, right? So grab that opportunity, because BEL having 200 vacancies and you can go for that. Their exam is not that much difficult, that is a GATE exam. You can prepare for that for revision. If you know the concept, you prepare for GATE well. If you know the concept, you want to prepare for that one, you can join this module. This module is only based for the questions, only for, we can say, the concept through the questions. We can go through here, we will discuss the questions. You can utilize that part of the questions in your exam. So hopefully this will help you. Thank you.